Hello everyone and welcome back to my channel. And as per our yesterday's discussion, that today we will see some RCFL exam, the analysis of RCFL exam and what is the expected cutoff. I know it's been a since month for this exam has been conducted on 1 November 2020 for mechanical and chemical branch. So here we will discuss mechanical part. Okay, so the exam was 45 question of 1 marks each, which included aptitude, reasoning, English plus GK and GS. Okay, so in this aptitude and reasoning, these two were time consuming portion. Many of students found the very it is very time consuming. Okay, English is moderate to easy, and GK is also good, very easy question. If you have studied for Coal India Limited or UPPSC or Vizag Steel, those who are preparing for since February 2020, so they might not have faced any problem. Now we will talk about 50 question next, that is 2 marks each, and all of them are technical. And from that 50, 45 were theoretical and 5 were numerical. In theoretical, majority of steam turbine, power plant, boiler, fluid mechanics. Okay, so this and heat exchanger, basically majority of portion of 45 question will be from this. Well, sorry, not will be, but it's the question was from 45. The majority of questions were from this thermal side, or you can say the thermodynamics background, and 5 questions were from numerical, and they are from theory of machine, and one is from machine design, basic simple spring index. And so this kind of the question. So now what will be the safe score? So I would recommend that as per my expectation. Okay, this is not exact, this is my expected. I'm here writing expected. This is the expected, that is if in 45 if we have correct more than 35 plus, and in technical if you score 40 plus, then it will be very safe score and you will be in safe zone. If you talk about cutoff, so for unreserved category, I will only talk about unreserved category because uh, you have to be, you are very clever enough that you will understand for different categories. So unreserved, I am I am expecting 103 out of 150. It is a safe score. Okay, so this is my expectation, and what is the actual, what will be the actual, it's only depend upon RCFL. So this was the RCFL analysis. Now let's see, this is the one query, and this was the one of queries sent in the Telegram group by Mr. Jay Shah. Okay, in our, he's our subscriber and also Telegram member. Okay, so he sent me some queries, and these are the some two queries that I found very good and I would like to share with you. Okay, so sorry, not Jay Shah, it's Jay Panchal, Mr. Jay Panchal, sorry. uh, actually there are lots of Jay in my group, so it is Jay Panchal, Mr. Jay Panchal, who sent me this question. So these two are very good questions, so let us see what are these questions. A company, first is from industrial management, first question is from industrial management, inventory, and second is very good, very good, and it is of production, metal cutting. So let us see first question. A company uses 2555 units items annually, that means in 1 year. So total demand we can write like this: 2 times 2 into triple five, 2555 units per annum, and the delivery lead time is 8 days. So the reorder point in number of units, in number of units we have to tell to achieve optimum inventory. So first of all, understand the meaning of this red line. So this highlighted or what I marked in the box, that word achieve optimum inventory. Here nothing is mentioned about the shortage. So optimum inventory is, that is no shortage. That means if there is a zero, like the inventory reached to zero on that day, the delivery of new units will come and our inventory level will be as initial. Okay, like 2555. Okay, so this is the meaning of achieve optimum inventory. That means on the day at which the inventory level goes to zero, on that same day the delivery will come of the units and your inventory will be rise as per initial quantity. Okay, but it will take lead time of 8 days. So if you order on the day when the inventory is zero, so you will be shortage of 8 days. So you have to be order before that 8 days. Here I am marking with yellow line, before 8 days. And here nothing is mentioned about. So here we will take a simple replenishment rate. That means it is the inventory is decreasing day by day as a gradually, not one day very high, not second no inventory use. So we have taken that inventory will daily the uses of inventory will be same. So lead time is 8 days. So we have to find that number of units. That means before 8 day how many quantities you have left, so that you will order on that day, and at the day of zero inventory you will have new stock. So here 8 days lead time and your demand is in year. So first of all you have to convert your demand into per day. So 2555 divided by 365, so you will get as a 7. So 7 units per day. Okay, so if you multiply with 8, so that means 56 unit. So when there is a 56 units in the inventory, you have to be reorder. So your answer will be 56. C option is the right answer. Now next, I'm here, I'm erasing this highlighting points, and again I'm going for 11th number question. This is metal cutting, and this is very good, and the chances of this time this kind of question in gate is very good, very high. In orthogonal turning, I'm underlining the all the major and what the key points in this question. That is, in orthogonal turning, first term is orthogonal turning of a low carbon steel, material is given and diameter is given 150 mm. It is uncoated carbide tool, yes, material tool material and workpiece material given. Cutting velocity is given 90 meter per second, 90 meter per minute. Feed rate is given 0.24 mm per revolution, and depth of cut is given 2 mm. The chip thickness obtained is 0.48 mm. That means after deformation the chip thickness will be 0.48 mm. If orthogonal rack angle is 0, orthogonal rack angle, not normal rack angle, it is orthogonal rack angle, it is 0, and the principal cutting edge angle is also given 90, then shear angle in degree we have to find. So some guys, what they will do, they know the equation of shear angle, tan phi, that is Ganesh ji formula, r cos alpha. Why I'm telling the Ganesh ji formula? Because one of our faculty was used to say this formula as a Ganesh ji formula. Okay, this is not my word, this is our faculty was telling. And we also asked, why sir, why you are telling this equation tan phi is equal to r cos alpha divided by 1 minus r sin alpha as a Ganesh ji? So he said that in GATE or ESC or any other PSU exam, whenever there is a metal cutting numerical problem, then very first you have to use this equation. Without using this equation you cannot go ahead, you cannot solve your entire problem. So that's why, and he said that in our day-to-day life we are always praying with praying to Ganesh Bhagwan, so that our work will be go easy and without any uh, distraction. Okay, so that's why he used to say the Ganesh ji formula. So what many people do, r is the chip thickness ratio, it is T by Tc, they will find, and alpha. So what some people do, here it is written orthogonal rectangle is 0, so they will only read this rectangle is 0 and they will put here alpha is equal to 0 and they will find, and the answer they will get is correct, but they get the answer only for this particular case only. If the principal cutting edge is changed from 90 to 60 and this orthogonal rectangle if they change from 0 to 5 degree, then they will be wrong. So what to do here, the first important term is orthogonal turning. Orthogonal turning, that is 90 degree, the lambda, it is 90, principal cutting edge angle is 90. Okay, and it is not as a usual of American standard ASS system. Here ORS system is we have to use because orthogonal rectangle and principal cutting edge is also given. So first of all, there is one relation, because whatever the formula here, tan phi is equal to r cos alpha, so this is the phi, that is shear plane angle, and alpha, that is back rack angle, alpha b more precisely if I talk, back rack angle. So these equation in ASA form, and the angles here given is in ORS, orthogonal rack system, ORS system. So first we have to convert this ORS angles into ASA angles, American standards of. Okay, so for that we have one equation, that is tan alpha b, that means back rack angle, is equal to sine side cutting edge, sorry, sine lambda into tan orthogonal rack angle plus cos lambda into tan inclination angle. And whenever it is nothing mentioned about any inclination, so this is the first the formula you have to remember. This, there are four formulas, one is for back rack angle, one is for side rack angle, one is for uh, the side cutting edge angle, and side relief angle. Okay, so we have to use the first equation of back rack angle. Now if in the question nothing is mentioned, then we will take inclination angle as a 0 degree. Okay, so here if we put all the value, that tan back rack angle is equal to sine 90 into tan 0, because orthogonal rack angle is 0, tan 0 plus cos 90, it's by default 0, and multiply by tan 0 0. Here sin 90 1, but 1 multiply by 0, that is 0. So tan back rack angle, tan of back rack angle is 0, so we can write the back rack angle as per ASA system is 0 degree. Okay, that's it. Now we can use that equation of Ganeshji. So but before that, chip thickness ratio, R is what, T by Tc, we know. And in orthogonal cutting, orthogonal turning, uncut chip thickness, here chip thickness ratio R is what, T by Tc. T is what, uncut chip thickness, and Tc is what, cut chip thickness, or the chip thickness after the machining. So it is Tc, the after machining it is given in our question, that is 0.48 mm, but this T is not given. So remember this, for orthogonal turning, initial chip thickness is given as f sin lambda. F is what, feed, 0.24 mm per revolution multiplied by sin 91. So initial chip thickness is 0.24 mm. So put all this value, 0.24 divided by 0.48, so you will get as a 0.5. Now you can use that Ganesh ji wala formula. So the formula is 10 backrack angle, sorry, yes, 10 backrack angle is r cos alpha, sorry, not 10 backrack angle, this is a shear plane angle 10 phi, that is r cos alpha 1 divided by 1 minus r sin alpha, backrack angle. Okay, alpha b, r is 0.5, cos 0, that is 1, divided by 1 minus 0.5, and sin 0 0, so numerator will become 1, so that is ultimately we will get 10 phi is equal to 0.5, 10 phi is equal to 0.5. So when you take the 10 inverse, you will get the phi as a 26.56, 26.56 degree. So this is the answer, and our answer is option B, 26.56. And uh, before the beginning of this question, I told that some people will do the calculation and they will get answer right when the angle is changed. So what happened here, if I let us take the example of principal cutting edge angle is 60 and orthogonal rack angle is 5. So here this lambda value and orthogonal rack angle will change. So so depending upon that, this backrack value will be changed. So in that case, this alpha would not be 0. Okay, or in case if that is a 5, suppose it is given as 5 orthogonal rack angle, so here it will not as a 5, it may be different. Okay, so this is the answer of the question. So that's it for today, guys. If you have still any doubt, ask in the comment section or in the Telegram group. You will get your solution of your query. Okay, so thank you very much for watching this video. Tomorrow or maybe on the next day we'll meet with another videos. Till then, keep studying, stay focused, stay safe.